Alright, now we're gonna start learn about the outlines and also the definition that we will discuss in this course. Alright, so the outlines, first we will learn about mineral resources, about the source from minerals or from partial processed materials or from recycled materials, and also we're gonna know about the products. The second one is to do beneficiation or physical mineral processing, how we beneficiate the minerals from the ores into a concentrate ore. And then we learn three types of routes to extract the metal: pyrometallurgy, hydrometallurgy, and electrometallurgy. Right. Let's start with the definition. For chemical engineers, at least we need to know what is actually metallurgical engineering. Metallurgical engineering is a discipline concerned with extracting metal from their ores and the development, production, and the use of metallic materials. Metallurgical engineering is based on the principle of sciences engineering and may be divided into a process metallurgy, which is concerned with extracting metal from their ores to make refined alloys, and physical metallurgy, which involves the shaping, alloying, heat treatment, joining, corrosion protection, and testing of metals. We will, as a chemical engineers, we also will learn about this physical metallurgy in the course of TK4046 about engineering materials. Now, what is process metallurgy? Process metallurgy is the science and technology of winning metals from their ores, how we extract the metal, and how we purifying the metals for the primary metal production. And sometimes it also referred as a chemical metallurgy. There are principles of mass and energy balance, the kinetics, the thermodynamics, the transfer phenomena. It is two chief branches are extractive metallurgy and refining. So, extractive metallurgy is the study of processes, use of separation and concentration of raw materials. The field is applied science covering all aspects of physical and chemical processes to produce mineral containing and metallic materials. Sometimes for direct use as a finished product, but often as a form that requires further physical processing. While, like I said before, metallurgy is much more like at the end stream, yeah, the downstream. So, how to shape metal parts, how to to make metal parts depending on the shape, property, and the cost. It can be the properties may be electrical, mechanical, magnetic, or chemical in nature, and all of them can be enhanced by alloying and heat treatment. Now let's talk about mineral resources. So the mineral resources characteristics we will what it will explain in this video. It first is a mineral, an ore, an organic compound. As a chemical engineer, of course, you know a lot about organic compound, the oil and gas and coal. So I won't be explaining this one much. So the first one is mineral and ore, organic compound, and also recycled material. Recycled material from urban mining, from scrap metals. It can be used as the mineral resources, and also partial processed materials that I will explain later. And also we will learn about product characteristic of the metal and also what is the properties of the final product. This graph shows a hierarchy of process aimed in minerals, metals, and materials production. I took this from Facebook. From the source, the main block diagram is separation. The separation from, because mostly in the source of mineral has a lot of gauge, not only the metal or the compound that we want, but also there's gauge material, for example, stone, rocks, or sand that we don't want. So we have to separate it to make it concentrated, and after that we need to do a processing. For the processing, there are three type of processing based on the output. The first one is compound formation. The second one is metal production, and the third one is metal purification. For example, a compound formation in West Kalimantan, there are chemical plant. It's called uh, Indonesia Chemical Alumina. So what they do is actually make alumina, Al2O3 from bauxite, and they just sold it as a product of chemical grade alumina. So it is actually compound formation. It's not metal because it's still alumina, but you still can sell it. The second one is metal production. For example, the Krakatau Steel or POSCO. Krakatau POSCO in Cilegon that produce steel, iron and steel. They make metal, and then you sold it as a primary metal, right? Okay. And the third one, for example, metal purification, where, for example, copper is sold as really pure because it is for the conductive material for electrical cable. So we need to have copper for like 99.999999, something like that. So we need metal purification after we got the copper bullion. Copper bullion is like a crude copper, like 98% copper. We have to do purification up to 99.99999, something like that. Okay, so and then after that all the product preparation and processing, and then we can sell it as a product.